In this video, we're going to learn about transformations. So transformations are just our way of moving about a two-dimensional figure in a two-dimensional plane. So I can slide my figure, I can flip my figure, I can rotate my figure, and I can make my figure larger or smaller. So we have 4 different types of transformations. 3 of these transformations are considered rigid transformations. Rigid transformations create figures that are congruent. So in purple here, I have our rigid transformations. So I guess I'll write it here. Rigid transformations. And that simply means that we are looking at transformations that do not change my size or shape. So if they don't change my size or shape, we are creating figures that are congruent. So same shape, same size. Dilation, which is the oddball out, does not count as a rigid transformation because a dilation changes our size. So if I'm dilating something, I am changing the size of that figure. So it's not rigid, it's just a transformation. So we can say that this is just a transformation. And dilations create similar figures, and similar means same shape, but not necessarily the same size. So we're going to go into details about all 4 of these, but we're going to remember that these first 3, the translation, the reflection, and the rotation, create congruent figures. So we call them rigid transformation. Dilation is a transformation that creates similar figures because it does change our size. So let's look specifically at each type of transformation. So first we have a translation. A translation can also be called, in simpler terms, a slide. So I'm going to write beside translation, I'm going to write the word slide. Because what is happening here is we're actually going to just be sliding our figure to a new location on the plane. So when we're asked to translate something, you are simply sliding each point that amount in that direction on the plane. So for a translation, we're going to just do 1 point at a time, and we're going to move it however many units they say in whatever direction they say. So this one says translate figure A, B, C, D, right 8 units and down 4 units. So what I'm going to do is 1 coordinate at a time. I'm going to move it right 8 and then down 4. So I'm going to start with A, and I'm going to go 8 to the right and 4 down. And I'm going to put a point. That is going to be my new point for A. So we're going to call it A prime. That's what that little 1 is up there. Then I'm going to move my next point. So I have 2 of them done. I'm going to move C and then D, right 8, 4 down. Once I have all of my coordinates, what I'm going to do is I'm going to connect my dots so that I have my new figure. So my new figure is the same exact figure I had before, just in a new location. So we're going to call this new figure A prime, B prime, C prime, D prime. And that's just the way that you can refer to an image that's been transformed. So we translated this image 8 units to the right and 4 units down. So if you are given the image and asked to say how much you translated it, just pick one coordinate and track its direction and the number of units. So I could pick my coordinate and its corresponding coordinate and count. That's how we do a translation. Algebraically, a translation has you add or subtract to the coordinate. So A is originally located at -4, 3. And then it moves to be 4, -1. So what happens in this translation from -4 to 3, or sorry, -4, 3 to 4, -1, is we are adding 8 and subtracting 4. So from our x value, we add 8, which makes sense because we're moving right 8. So our x value increases by 8. Where we're moving down 4, so my y value decreases by 4. That's how we look at this algebraically. So if I were to say the transformation x plus 8, and then our y minus 4, we know that this is representing a translation. And what's happening to the x is we're moving right or left, right being positive, left being negative, and what's happening to the y is my up or down. If this confuses you right now, just focus on what is happening visually, and the more that makes sense, hopefully the more this part will make sense. A reflection is another type of rigid transformation. So with a reflection, we are reflecting our image. The trickiest part of a reflection is when your figure is already located on multiple sides of your line. So that's why I picked this figure to use, because it's on this side of our y-axis and this side, and it's on this side of our x and this side. So hopefully when we start doing it, this will make a little more sense. So my first step here says reflect figure ABC across the y-axis and then across the x. So what I'm going to do in order to reflect this image across the y-axis is I just need one coordinate at a time to count how far it is away from the y-axis, because that's what we're doing first, and put it that many spots on the other side of y. So just like with our translation, we're doing one coordinate at a time. We're looking at our y-axis. That's what we're reflecting across. A is 3 units from my y-axis. So I'm going 3 units onto the other side to put A prime. C is 1 unit from the y-axis. So I'm going to go 1 unit to the other side to put C prime. It can feel tricky because B is already on this side with A and C, but we haven't moved it yet. So we need to actually just go the other way because it's 1 unit to the right of our y-axis. So we're just going to place B prime 1 unit to the left. You're just always going to the other side than it was before. So B prime, and then I can connect these dots. So what we have created here is a mirror image, or we've just simply flipped our image across Y. Then it wants us to flip it across X. So I'm going to flip A prime, B prime, C prime across X now. So this new image is going to be, choosing my colors. Let's use this dark green. This time I'm going across X. So X is our horizontal. So this time, each coordinate, I'm counting how far it is from that line of symmetry. So A prime is 2 units above X. So A prime prime needs to be 2 units below X. C prime is 2 units below. So C prime prime needs to be 2 units above. And this time we just have a little 2 because it's after we've done 2 transformations. So we have 2 little tallies called prime prime. And then B prime is 1, 2, 3, 4, 5, 6, 7 units above the X. So we need to go 7 units below X. And that is going to be where B prime prime is. And then I can connect these dots. So that is after we have flipped or reflected. That's our keyword. I did not write that earlier. So we're calling this is our flip. Or you can call it your mirror. We mirrored or flipped across Y and then across X. Make sure you know what line of symmetry you are working with before you do your reflection. It will tell you the y-axis or it'll tell you the X. This can also be represented algebraically like our translation. Algebraically, a reflection across Y. So this initial reflection, so from A to A prime, we had, I guess I'll go right here. A was at -3, 2. And A prime is at 3, 2. What happens is we are flipping the sign of our X value. So Y stays the same when we have a reflection across the y-axis. Algebraically, it goes from X, Y to -X, Y. And then if you reflect across X-axis, what's happening this time, so from A prime to A prime prime, A prime prime is 3, -2. This time you're flipping that Y value. So X stays the same and you get the opposite sign for Y.